Hello everyone, welcome back to the Lee County Library Science Club. It's great to have you with us once again. Just a reminder, please make sure you have your parents' permission and some supervision when you're doing these experiments with us. Now, I'm sure you've noticed I use the word experiment to describe what we're doing every week when we do these. But if we're being really honest about it, the things that we've done so far are not really experiments. They're more scientific demonstrations, right? We talk about a principle of science and we demonstrate how it works. An experiment is something a little different because to be a true experiment, you have to be testing something. And so what we're going to talk about this week is what's known as the scientific method. Now this idea is the basis of all of our modern science. It is the process by which scientists are able to find answers to the questions they have about the world around us. Basically, it is thinking about questions and thinking about the world in a certain way so that you can find the best answers possible. And this is how our modern scientific research is done and how our modern scientific community has been able to make such great advances over the last, about 150 to 200 years. Now the scientific method is not a real, concrete, solid idea. It has changed over time. It developed different ways in different places. And even now, it's not always talked about the same in every situation. But in general, the idea behind the scientific method is that if you follow a series of steps, you will be able to analyze a question or a problem, come up with an idea of what you think will be the solution to that question, and then test your solution to see if it's correct. So generally, there are between 5 and 7 steps in the scientific method. The first step, and what can often be the hardest step, is ask a question. Find something in the world around you that either doesn't make sense to you or intrigues you enough that you want to know how it works. The second step is to do research. Try to find out if others have asked the same question you have, and if they have, find out what answers they came to. Step 3 is to form a hypothesis. A hypothesis, you've often heard, is what is called an educated guess. So you take all the research you did about your question and you kind of pile it together to say, this is what I think will happen, or this is what I think is behind the question that I'm asking. Step number 4 is to test your hypothesis. And in this step, you are designing an experiment to test your proposed solution of a hypothesis against your question. Step 5 is to analyze your results. Okay, look at what was the outcome of your experiment. Decide, did your experiment actually test what you wanted it to test? If so, what did it say about your original question and your hypothesis? Did it confirm it? Did it prove it false? Was it maybe not really conclusive? You have to go back and analyze what the data from your experiment says. The next step may not always happen. It is what is known as iteration. Iteration means to repeat something. Okay, so this is taking your experiment and your data analysis and then changing your experiment to try to improve what your data said or to try to get a more accurate result from your data. And you would do that as many times as you need to until you come to what you believe is the best result you can get. And the last step in the scientific method is to communicate or share your results. In the scientific community, you'll often hear about something called a peer-reviewed journal. This is where a scientist has come up with a hypothesis. They have performed experiments to support or disprove their hypothesis. They've taken all those results and they have shared it with other scientists. Those other scientists then look at the data and the experiment, and they together will say whether or not it seems really realistic or true, or if maybe the original person didn't do a good job. And this is a very important step. We need scientists to be able to be accountable to each other so that we can get the best, most accurate, and most truthful theories about our world. So today, we're going to take a fun little demonstration about candy hearts in soda and turn it into a real experiment using the scientific method. So to begin our experiment, we need to go back to the beginning of the scientific method. The first step is to ask a question. Well, the question I have decided to ask, because it's February and it's Valentine's Day and they're selling the conversation hearts, which are so much fun. And they're even more fun if you actually put the conversation hearts in a glass of soda. They will bounce up and down and dance due to the way that carbon dioxide in the soda interacts with the candy hearts. Now, that is a demonstration. To turn it into an experiment, we need to ask a question about that interaction. So my question is, does it make a difference what kind of soda it is and what kind of candy hearts it is? So does changing the parts of the reaction, does that change what the result will be? Now the second step is to do some research. Obviously this is a short video. We're not going to go through all the research together, but I did do a little bit of research beforehand. And in general, what we come up with is soda is made up mostly of sugar, water, and carbon dioxide. Sometimes the sugar is in the form of corn syrup. Sometimes it's in the form of actual cane sugar. It just depends. Now it's true some of them don't have actual sugar, but they do still have elements in them that resemble and take the place of sugar. So we're going to see if real sugar or replacement sugar has an effect on this interaction. I also have two different kinds of candy hearts. We have the Sweetheart brand candied hearts, and we have the Brock's candy hearts. Now, going a little bit deeper, there is a difference in the sugar content of each of these things. If we look at this can of Coke, there is 39 grams of sugar in this can of Coke, which, if you know anything about sugar, that's a lot. Soda is not good for you. In this Sprite, there are 38 grams of sugar. In this Coke Zero, there are 0 grams of sugar, but like I said, there is a sugar replacement in there. And in this case, that is what is known as aspartame. It kind of mimics the effects of sugar without actually being sugar. And there is also a difference between our candied hearts. In the Brock's candied hearts, there is 19 grams of sugar per 26 grams of candied hearts. Now just that in itself should tell you that these candied hearts really are mostly made of sugar. But it's still different depending on which one, because in these Sweethearts over here, there is 22 grams of sugar per 26 grams of actual candied heart. So what that means is there's a little bit more sugar in each one of these candied hearts than in these candied hearts. The hypothesis I am putting forth is that different amounts of sugar in the soda and in the candy will make a difference in how extreme the interaction is. How quickly the candied hearts bounce up and down or dance will depend on what type of candied heart and what type of soda it's in. Now, we need to design an experiment. The biggest thing about an experiment is that there needs to be variables that you can change. So, for each of these, we have a soda and a candied heart. What we're changing is the type of soda and the type of candied heart. But we can't mix and match. We need to make sure we have each type of candied heart goes into each kind of soda so that we can really see the different interactions. That will be our experiment. Now, ideally, in an experiment, you would want to be very precise with the data that you are collecting. That would be something like timing how quickly the candied hearts move, how long it takes for all of them to be moved, how long it takes for the carbon dioxide to release out of the soda. That is something you can definitely do. That's something I would encourage you to do on your own. But I don't really have time to be quite so precise in this quick video. So what we are going to do is we're going to fill each of these glasses with the soda. We're going to take a specific number of candied hearts. In this case, that will be 6. So we'll put 6 pieces of candied hearts in each jar, and we'll see if those interactions differ at all. And that will kind of be our analysis. And I hope you can realize my sharing and communicating is this video. You guys all get to see our experiment, and if you want to, you can do it at home to verify my results. Alright, so first things first, let's get the soda into the jars. Now you'll notice I have Coke, Sprite, and Coke Zero for each type of candied heart. Alright, here we go. Okay, we've got our soda ready. Now let's count out 6 hearts for each jar. So I've still got a lot of candy in here. I'm going to go ahead and make it more like 10 in each one, just so we can really have fun with it. Okay, now that we're all set, I'm going to try to put them in as quickly as possible so that we can really observe what's happening side by side. Okay, are you ready? Here we go. Alright, we've got them in there. You can see already they're fizzing quite a bit. We're going to try to see when they start to move. Oh, we can see this one over here is already starting to move. We've got one coming up over here. Oh, these ones are still not moving yet. So already that's a difference in our results. Oh, this one's got another one moving. This one, they're starting to move around a little bit. Oh, I've got one up over here. So already we're able to see that the sweetheart hearts are moving and reacting much more quickly than the Brock's hearts, right? So having more sugar in here, or maybe just less of the other ingredients like the gums and the things that hold it together, this is reacting more quickly than these are. And you can definitely tell that the sugar content really does have an effect on this. Because over here, this is our Coke Zero right here, with no real sugar in it. It's just the aspartame. And if you look, the Sprite and the regular Coke, the ones with 38, 39 grams of sugar in them, they have the hearts moving and bouncing up and down already. But this Coke Zero over here, they're just staying on the bottom. So it's really interesting, these Brock's hearts on this side, they've been in there for quite a while, but they haven't started moving at all. What we do have though, if you can look at the top of them, you see there's some coloring on there. And so it looks like instead of the carbon dioxide latching onto the hearts and bringing them up to the surface, it's actually dissolving the hearts instead. So there you have it, that the content and the makeup of these candied hearts is definitely different, and it has a real effect on the interaction between the soda and the candied hearts. And so that right there, that's our analysis. That's how we say whether or not our hypothesis was correct, and whether or not our experiment demonstrated our hypothesis well. So if you go back, my hypothesis was the sugar content and the makeup of both the soda and the hearts is going to have an effect on the reaction between the two. And here we have our proof that the reaction really is different depending on what soda is used and what candy is used. I know we really came to just have a lot of fun with the dancing hearts, right? So, we are going to have a little more fun. This Sprite seems to be the most reactive, right? The Sprite with the sweet hearts in it has been our most active. You can even see now it still has some moving. So, we're going to zoom in on that one. And now we're going to pour in a whole bunch of hearts and just see what happens. Ready? Here we go. Woo! You can see it's fizzing up a whole bunch. Oh, and already they're starting to move more. Alright, so while we watch those hearts dance for a little longer, I hope you really are able to get an understanding of what it means to employ the scientific method. Okay, we were able to ask a question. Does the makeup of the soda and the candied hearts affect the interaction? We did some research. We learned about the different sugar contents of the sodas and of the hearts. And we were able to form a hypothesis, right? We said, yes, the sugar content of the soda and the candy will affect the interaction. Now, we weren't quite able to give a hypothesis as to how it would affect it, but that's also part of the reason for the experiment. So next we were able to test our hypothesis. We set up 3 different sodas and 2 different candied hearts and put them in each of them, and we saw what happened, right? We're able to analyze those results by just looking at them side by side. That's not the most official analysis, but it's pretty obvious when we're looking at it, right? You could see clearly that the Sweetheart brand reacted much differently from the Brock's brand, and we saw that the Sprite reacted more quickly than the Coke. And we even saw that the Coke Zero barely reacted. In fact, just now, almost 5 minutes later, we just got some movement in the Coke Zero. So it was definitely different. Now, we didn't need to iterate this, right? We could if we wanted to really get more accurate readings. But just to be able to prove our general hypothesis, yeah, the sugar content was shown to make a difference in the reaction. And so now, I share it with you, and I encourage you to go do your own experiments. Maybe get more different brands of candied hearts. Maybe get more sodas. Okay? Maybe see if the soda being warm or cold makes a difference in the reaction. Okay? There's lots of different variables that you can change to make your experiment as accurate as possible. Just remember, keep careful track of those variables so that you know which one is which when you're doing your experiment. Thank you so much for watching. I hope you really enjoy this one, and we'll see you next time. Bye!